My name is Charmin, enrollment number 5 of Instrumentation and Control Engineering Department last year, along with my teammates Jigar Desai, enrollment number 11, and Devanshi Trivedi, enrollment number 61. Now, this demonstration is a part of my last year's project, that is Smart Water Management System, as by its name. So, here I am going to demonstrate the flow meter which I have designed along with my group mates. Now the system that is shown here consists of a microcontroller, that is Arduino, along with an LCD which displays the readings, and a relay module and a flow sensor. Now this flow sensor is based on the principle of Hall effect, and here is a solenoid valve. Now let's see how this system basically runs. First, we shall look at the block diagram of the system, and we will consider the left hand part of the block diagram, which shows a house, a flow sensor, a solenoid valve, as shown in this presentation. Now here it is evident that the flow sensor will monitor the flow rate of the water flowing through the taps in the houses, and the system is designed such that if the flow sensor continuously monitors that, as for an example, the flow through the taps is continuous for, let's say, 15 minutes or 20 minutes, which is an indication that the water is getting wasted through the taps, because generally the tap is never on for this long time. So the microcontroller, the Arduino or any other microcontroller, what it will do, it will turn the solenoid valve off, which will prevent the water flowing through the taps from the house, and all its taps or all water utility supplies. Now the solenoid valve that is there here is a 24 volt solenoid valve. Now this solenoid valve can of course run at 24 volts DC, but it can also run at 18 volts DC. So to give the proper power supply to the solenoid valve, this is a power supply which has been designed by our group, and the power supply has 24 volts DC, 18 volts DC and 12 volts DC. The 12 volts DC is also used to drive the pump, which is also a part of our project. And from the 18 volts I am giving it to the solenoid valve. Now this solenoid valve is basically a normally closed solenoid valve. So if the water has to flow through the system, then the solenoid valve has to be continuously on. So right now the solenoid valve is on, and I have connected the solenoid valve through this relay such that the solenoid valve is connected to common and NC, which makes it energized. And when the microcontroller turns on, it gives a signal to the relay to turn on. Thus the solenoid valve will turn off. So the wiring diagram is just a reverse, a little different, but it basically functions in the right way. So now let us start the system. Now before that we will look at the programming part. The programming is done in such a way that if the water through the system is running continuously for more than 8 seconds, and the flow rate of the water, if it is more than 70 milliliters per second, then the solenoid valve will turn off, and a message will be passed to the user, to his or her phone, that water was getting wasted, whether the user is aware or not, and the solenoid valve has turned off, which will make the water stop from flowing into the taps. Once the user acknowledges and gives a yes command after solving the problem, the water will start flowing through the system again, and in this way the water wastage can be prevented. So now let's start the demonstration. So this is the serial monitor onto which we can see the readings. The same readings can also be seen on the water meter, on the display, LCD display. The same readings are there. Right now only 3 milliliters of water has been consumed, and thus the water bill is 0.1 rupees. Now let's also see the calculations for the water bill. Now this is just an example. The calculations are made such that for every 1 milliliters of water consumption, the user will have to pay 5 paisa. Okay, and if the user exceeds water consumption, then the rates will get double after 1 liters of water consumption. This is just an example. However, the calculations will be different in real time. Right now we can see that the water supply is on. As it can be seen here as well. Now I will pass some water through this flow sensor and we will see that the readings will get changed because the water will started to consume by the user. So 3.7 liters per minute was the flow rate and the current liquid flowing was 63 ml per second, only a change in the units, and the output quantity was 66 ml, so which means that 66 ml of water has flown through the system, and thus the monetary rate, the bill amount, is 3.2 rupees. The water supply is on because water was not getting wasted. Now what we will do is we will make the water get wasted through the system, and we will see that this solenoid valve will turn off to prevent the water wastage. Now if the water were getting wasted, you will hear a click sound. So now you must have heard that click sound, and a message has been passed to the user that the water was getting wasted. Are you aware? The user has to type yes or no. The user will type no if the user is out of the house and he is somewhere outside, so he cannot turn off the taps, and the water supply has been turned off, so water is not getting wasted anymore. The same thing is displayed onto the water meter on the LCD, that the water supply is off. Note that the LCD is not giving any other displays or any other readings because the system has turned off. Basically the system has not turned off, the relay has turned on, which will make the solenoid valve turn off. Now let's assume that I am the user and I'm out of home, so basically I will give a no command to the system, and let's see what happens. The system has given me the instruction that my reply was no, and I will have to solve the problem as soon as possible, and I'll have to type yes when I have solved the problem so that the water supply can be restored. Now let's assume that I am back home and I will give command Y as a yes to the system, and let's see what happens. Now when I press the enter, the system will get the command yes, and you will see that the relay will turn off, which will make the solenoid valve turn on again, and you will hear the click sound. So the solenoid valve has turned on and the water supply has been restored. The same message will be given to the user back that your reply is yes, alright, things are fine, water supply is on. Now if you see, then I said that if the water supply the flow rate, if it were more than 70 ml per second for more than 8 seconds, then the relay will turn off, which means that if you can see here, 90 milliliters of water was flowing per second. That is why the relay turned on, which had made the solenoid valve turn off. Moreover, the water consumption was 431 ml till right now, and if you multiply it by 5 paisa per second, then you will see that 21.5 rupees has to be paid as the water bill, and the water supply is again restored to the normal. So this is the part of the water meter that is designed, and the level sensing of the overhead and underground tanks is there in the next video. Thank you.